Welcome to our deep dive into quantum computing. Looks like you've been exploring stuff like Quantum Computing Simplified by Ramayana.
Yeah, it's such a cool topic.
So we'll break it down and see how it could change things, in the future.
It's a really exciting time to be looking into this. Quantum computing, it's not just about faster computers.
Right.
It's like a totally new way of thinking about computation.
Okay.
And it's all thanks to quantum mechanics.
I'm intrigued already. So I know, regular computers use bits, those zeros and ones. But
Yeah.
in quantum computing, it's all about qubits.
Exactly.
And a qubit can be both 0 and 1 at the same time. How does that even work?
Yeah, so that's called superposition.
Okay.
And you can think of it like a spinning coin. It's both heads and tails until you stop it.
Okay.
And this lets quantum computers explore tons of possibilities all at once.
Wow.
Like, imagine searching a maze. A classical computer has to check each path one at a time, right? But a quantum computer can check all the paths simultaneously.
That's incredible. No wonder people are so excited about this.
Yeah.
So how did we even get to this point, though? I mean, was it a sudden leap, or were there, clues along the way?
Well, it's been a pretty fascinating journey. I mean, even early tools like the abacus,
Oh, wow.
they had this core idea of representing numbers.
Mm-hmm.
Then you had mechanical calculators, to automate basic math.
Yeah.
And then came things like the analytical engine. It was actually programmable using punched cards. So all of these early ideas, they kind of laid the groundwork for the computers we use today.
So we've always been kind of pushing the boundaries of what's possible with calculation.
Right.
So when did things really shift from, mechanical gears to the electronic age?
Well, the invention of the transistor in 1947, that was a total game changer.
Yeah.
It allowed for smaller, more efficient computers.
Right.
And that led to, the rapid growth in computing power that we've seen. We call it Moore's Law. But here's the thing. As we make transistors smaller and smaller, we squeeze them down to the atomic level, we're kind of hitting the limits of what classical physics can handle.
So it sounds like quantum computing is not just about speed, it's about breaking through those physical barriers.
Yes, exactly.
Tell me more about this quantum realm, though. Superposition is one thing, but I've also heard about entanglement,
Right.
which sounds even stranger.
Yeah, entanglements, it's really mind-boggling.
Oh, wait.
It means that two qubits can be linked, even across vast distances. So if you measure the state of one qubit, you instantly know the state of the other.
Wow.
It's kind of like two dice that always roll the same number, no matter how far apart they are.
That's where the spooky action at a distance comes in, right?
Exactly, yeah.
So how do these concepts actually translate into a real advantage over our everyday computers? What's the benefit?
So classical computers are great for everyday tasks,
Right.
but they struggle with problems that involve a vast number of possibilities. Like, for example, simulating how molecules interact for drug discovery.
Yeah.
Quantum computers, because they use superposition and entanglement,
Yeah.
they can tackle these kinds of problems much more effectively.
From what I've read, it seems like these quantum algorithms,
Yeah.
they're specifically designed to take advantage of that.
Exactly.
Quantum Computing Simplified talks about Shor's algorithm,
Right.
which is, it's famous for factoring large numbers. What are the implications of that?
So Shor's algorithm could potentially break the encryption that we use for online security, but it also paves the way for new quantum-resistant methods.
Oh.
It's kind of like a code breaker, finding patterns in a message to crack it. And then there's Grover's algorithm, which is used for searching massive databases.
Okay.
And that could revolutionize things like drug discovery and data analysis.
That's pretty powerful stuff.
Yeah.
But we need the physical quantum computers to actually run these algorithms.
Right? Yeah.
What's the hardware situation like?
So there are several different approaches, and each one has its own pros and cons.
Okay.
Some use superconducting circuits, which need to be kept at super low temperatures.
Mhm.
Others use trapped ions, which are individual atoms held in place by electromagnetic fields.
Wow.
And there are also photonic quantum computers, which use particles of light.
It sounds like a race to see which technology will come out on top.
Yeah, kinda.
What are some of the big hurdles in building these quantum computers, though?
Well, one major challenge is decoherence.
Okay.
And that's where the qubits lose their quantum properties because of interference from their surroundings. It's kind of like trying to write on a chalkboard that keeps getting erased.
Yeah.
And then there's error correction. Qubits are prone to errors, so we need ways to protect the information that's being processed.
It sounds incredibly complex, like trying to build a house of cards in a hurricane.
Yeah, in a way, yeah.
But even with all those challenges, researchers are making progress, right?
Oh, absolutely. Yeah, we're seeing new qubit designs, error correction techniques, and advanced control systems being developed all the time.
Mm.
And companies like IBM and Google are building increasingly sophisticated quantum processors.
Yeah.
And the really cool thing is that they're making these processors available through cloud platforms.
That's awesome. So it gives researchers and developers a chance to experiment without needing to build their own hardware.
Exactly.
Speaking of advancements, I keep hearing this term, quantum supremacy.
Right.
What does that even mean?
So quantum supremacy is the point where a quantum computer can outperform any classical computer on a specific task.
Okay.
And Google claimed to have achieved this back in 2019 with their Sycamore processor.
Okay.
And their experiment involved a task that was specifically designed to show this quantum advantage.
So that's a huge milestone. Even if there's some debate about whether it was true supremacy, it
Right.
shows the potential, right?
Yeah, absolutely. And ultimately, the goal is quantum advantage, where these quantum computers are solving real-world problems, with practical applications.
Okay.
Imagine things like personalized medicine based on your genes, or new materials that could revolutionize energy production.
That's a future I want to be a part of.
Definitely.
So we've got these incredibly powerful algorithms,
Yeah,
and this cutting-edge hardware is being developed.
right.
What are some of the specific applications we might actually see for quantum computing?
Well, why don't we dive into those after a quick break?
That's it.
When we come back, we'll explore how quantum computing could impact fields from medicine to material science and beyond.
I can't wait. So before the break, we were just about to explore how quantum computing could actually change the world.
Right.
I'm especially interested in its potential impact on healthcare.
Yeah,
It just seems like something straight out of science fiction.
it really does. I mean, one area that really stands out is drug discovery. As Quantum Computing Simplified points out, developing new drugs, it's incredibly complex
Right.
and expensive. And quantum computers could significantly speed up that whole process.
Yeah, I was reading about that. From what I understand, like simulating how molecules interact,
Right.
that's key to understanding how drugs work.
Exactly.
And that's something that classical computers really struggle with.
They do. It's way too complex for them. But quantum computers, because they operate on the same principles that govern those molecules,
Okay.
they can simulate those interactions at a much deeper level.
So it's like having a virtual lab
Yeah, pretty much.
where you can test thousands of potential drug candidates
Right.
without actually having to physically synthesize them.
Exactly.
Wow. That could really revolutionize how we treat diseases like cancer and Alzheimer's.
Yeah, absolutely.
What other healthcare advancements could we see?
Well, personalized medicine is another really exciting area.
Okay.
Imagine using quantum computers to analyze your individual genetic makeup.
Right. And then design treatments that are tailored just for you.
It's like having medicine that understands your body on a molecular level.
Yeah, exactly.
That's incredible.
Yeah.
What about medical imaging? Could quantum computers help there too?
Oh, absolutely. They could totally revolutionize medical imaging, allowing us to see inside the human body with just incredible clarity.
Wow.
And that could lead to earlier and more accurate diagnoses,
Right.
potentially saving lives.
It sounds like quantum computing could lead to a whole new era of healthcare
Yeah,
that's personalized, predictive, and preventative.
that's the goal.
It's really mind-blowing to think about. But shifting gears a bit, how might this technology help us tackle more global issues, like climate change, for instance?
Well, climate change, it's such a complex problem, and
Yeah.
addressing it really requires a deep understanding of how Earth's climate systems work.
Right.
Quantum computers could help us build much more accurate climate models.
By simulating the interactions between, the atmosphere, the oceans, the land, and human activity.
I was reading in Quantum Computing Simplified that those interactions are so complex that classical computers just struggle to capture them fully.
You do.
And that leads to a lot of uncertainty in climate predictions.
Exactly. Yeah. But quantum computers, they have the potential to process massive amounts of climate data
Okay.
and simulate those interactions with much greater accuracy.
Because that could give us a much clearer picture of future climate scenarios.
Right.
And help us develop, more effective ways to address climate change.
Exactly.
So we could potentially have a more accurate understanding of the impacts of climate
Yeah.
change
Yeah.
and even explore new technologies for carbon capture, for example.
Exactly. And quantum computing could also be used to, like, optimize energy production and distribution,
Okay.
making our energy systems more efficient and sustainable.
It's really fascinating how a technology that's developed at such a tiny scale,
Right.
at the subatomic level,
Yeah.
could have such a huge impact on a global scale.
It really is, yeah.
It shows how interconnected everything really is.
Yeah, for sure.
Speaking of manipulating things at the atomic level, what about material science? What could quantum computers bring to that field?
Well, materials science is all about understanding and designing materials with specific properties.
Right.
And quantum computers could totally change this field by simulating the behavior of materials at the atomic level.
Okay.
It's essentially like giving researchers a virtual materials laboratory.
So you could experiment with different atomic structures and compositions
Right.
to create materials with completely new property.
Exactly. Imagine materials that are lighter yet stronger
Wow.
for use in, aerospace or construction, or materials with unique electrical or magnetic properties for more advanced electronics.
I can see how that would be revolutionary. Could quantum computing also help us develop new catalysts for chemical reactions?
Oh, definitely. And that could lead to more efficient and environmentally friendly industrial processes.
It's amazing to see how quantum computing is moving from just theory to real-world applications.
Yeah.
But aside from these specific examples, how might it change our daily lives in a more broader sense?
Well, I think some applications might seem kind of distant from our everyday experiences,
Right.
but I think the impact will likely be felt in many ways.
Okay.
For example, think about more powerful AI
Yeah.
driven by quantum algorithms.
So we could have like smarter personal assistants,
Yeah.
more accurate medical diagnoses,
Right.
and even like recommendations that are tailored to our own individual preferences.
Yeah, pretty much.
It's like having a hidden quantum layer working behind the scenes to make our lives more efficient.
Yeah.
What about cybersecurity, though? How would quantum computing affect, such a crucial field?
Well, cybersecurity faces both challenges and opportunities with the rise of quantum computing. On the one hand, quantum computers could potentially break the encryption methods that we currently rely on to secure, our online communications and data.
That sounds like a huge threat to our digital security.
It is a concern, yeah. But the good news is that researchers are already developing new encryption methods.
Okay.
We call it post-quantum cryptography,
Okay.
and it's specifically designed to resist attacks from quantum computers.
So it's like a race against time
Kinda,
to
yeah.
implement these new security protocols before quantum computers become powerful enough to crack the current ones.
Exactly.
Are there any ways that quantum computing could actually improve cybersecurity?
Oh, definitely. For example, quantum key distribution, it uses the principles of quantum mechanics to create virtually unbreakable encryption keys. And quantum technologies could also be used to detect and prevent cyber attacks more effectively,
Right.
offering, a new layer of protection for our digital infrastructure.
So quantum computing could be both a problem and the solution for cybersecurity.
It's a bit of both, yeah.
What are some of the other trends and developments that we can expect to see in the future?
Well, one big trend is the increasing availability of quantum computers through cloud platforms.
Okay.
Companies like IBM, Google, and Microsoft,
Yeah.
they're making their quantum processors accessible to researchers and developers worldwide.
So anyone with an internet connection could potentially experiment with quantum computing.
Exactly.
That's incredible.
It really is. And it's becoming more affordable, too.
Okay.
And this trend, it's likely to continue. And that's going to make quantum computing more accessible to a wider range of people.
Yeah.
We're also seeing the development of hybrid quantum classical systems
Okay.
that combine the strengths of both types of computers.
So it's like having the best of both worlds.
Right.
What other advancements are on the horizon?
Well, another exciting trend is the development of more specialized quantum computers.
Okay.
Things like quantum annealers, which are designed for solving optimization problems.
Right.
And we're also seeing research into photonic quantum computers,
Yeah.
which could be more scalable and actually operate at room temperature.
This is all so fascinating. It seems like we're really on the cusp of a new technological era,
Yeah,
and the possibilities are just limitless.
I agree. I think we're only just beginning to understand the full potential of quantum computing. It's an incredible journey of discovery.
This deep dive has been an amazing exploration of the quantum world.
It has, yeah.
We've gone from, like, the fundamental concepts to potential applications, the challenges ahead, even touching on its impact on society.
All right.
It's really clear that quantum computing is poised to revolutionize so many aspects of our lives.
Yeah,
And it's exciting to be along for the ride.
I totally agree. Quantum computing is truly one of the most transformative technologies of our time. And like you said, we're just getting started.
Before we wrap up, I want to take a moment to think about the bigger picture. Like, what does this all mean for humanity? What are your thoughts on the wider implications of quantum computing?
Well, that's a great question, and it's one we should definitely dive into. So, we'll be right back to discuss the wider societal impact of this revolutionary technology and what it all might mean for the future.
We're back for our final look at quantum computing. We've seen how it could revolutionize things like medicine and material science.
It's really amazing stuff.
But now I'm kind of wondering, what about the bigger picture? Like, how will quantum computing affect, society as a whole?
Yeah, that's the big question, right? I
Yeah.
mean, it's clear this technology has the potential to be as transformative as, like, the internet
Right.
or even the invention of the transistor.
Right.
But with that kind of power, comes great responsibility.
Yeah.
We need to think really carefully about the impact on society and make sure we're using it for good.
Well, one thing that comes to mind is, jobs. Will quantum computers make certain jobs obsolete? I mean, that's kind of unsettling to think about.
Yeah, I mean, it's natural to have those concerns. I think it's possible that quantum computing could automate some tasks that are currently done by humans.
Yeah.
But I think it's also likely to create new jobs
Right.
and new industries that we can't even imagine yet.
That makes sense. I mean, it's kind of like in the early days of the internet, you know,
Right.
no one could have predicted the rise of, like, social media managers
Yeah.
or e-commerce specialists.
Exactly. And I think the key is to, adapt and embrace the changes that quantum computing will bring.
Right?
And I think we need to focus on education and training so that
Mhm.
people have the skills they need for a quantum-enabled future.
So instead of fearing, like, job displacement, we should be more excited about the opportunities
Yeah.
for new skills and careers.
Exactly. I think the people who are willing to adapt and learn, they'll be the ones who thrive in this new era.
Another concern I have is, the potential for widening the gap between those who have access to this technology
Right.
and those who don't.
Yeah.
How can we prevent that?
That's a valid concern, and I think we need to be really proactive about it.
Okay.
We need to make sure that quantum computing benefits society as a whole,
Right.
not just a select few.
Yeah.
And I think that means promoting equitable access to education, to research, and to development.
So it's not just about the technological advancement, it's also about social equity.
Yeah, absolutely.
Everyone should have the opportunity to benefit from this transformative technology.
I agree.
What can we do to inspire and educate the next generation of quantum scientists and engineers?
Well, I think we need to start introducing these concepts in schools and universities.
Okay.
Make quantum mechanics more accessible
Right.
and engaging for students of all ages.
Yeah.
Resources like Quantum Computing Simplified,
Right.
those are a great starting point.
Yeah.
And there are so many online resources and courses and workshops available.
It sounds like it's a great time to be learning about this field.
It is. It absolutely is. And it's not just about the technical skills either. I think we need to encourage, creativity, critical thinking, problem-solving skills.
Those will be essential for navigating the complexities of a quantum-enabled world.
Absolutely.
That's a really good point. I mean, quantum computing is going to require us to think differently,
Yeah,
to approach problems in new ways.
exactly. Yeah. I think we need to foster this mindset of, innovation
Yeah.
and exploration in the next generation.
Mhm.
Give them the tools they need to really shape the future of this technology.
Well, this deep dive has been an incredible journey into the world of quantum computing.
Yeah.
We've gone from, like, the basic concepts to potential applications, the challenges ahead, even touching on its impact on society. It's really clear that quantum computing is going to revolutionize so many aspects of our lives.
I agree.
And it's exciting to be a part of it.
It really is.
Thank you so much for joining us on this quantum adventure.
It's been my pleasure.
We hope this deep dive has sparked your curiosity and given you a really solid foundation to keep exploring this fascinating world.
Keep asking questions, stay curious and embrace the possibilities that this incredible technology offers. Who knows what amazing discoveries await us in the future of quantum computing?
Until next time, keep exploring.